Okay, in lesson 4, we're going to talk about some complements. All right, 42%. Okay, sorry, we're on page 21. We're going to look at this question. 42% of these light bulbs are fluorescents. 23 are long life. 12 are fluorescent and long life. A light bulb will be selected at random from the light bulbs at the store and find the probability that the selected light bulb is not fluorescent. Okay, well the probability of fluorescent is 0.42, so the probability it's not fluorescent would be the opposite of that, so it would be 0.58. You either are or you aren't, so they have to add the 1. All right, probability the light bulb is fluorescent given that it's labeled as long life. Well, okay, so this formula is this. Probability of F and L over probability of L. This is another formula. So probability of A given B is the probability of A and B over the probability of B. Okay, you need to know that. So fluorescent and long life, 0.12, over the probability of long life is 0.23. Now you can't break these up and cross these out to just get probability of F, because these depend on each other. Based on the way this is, they are definitely depending on each other because they're sharing some things too. So 0.112 divide 0.23, 0.52. Are these events independent? Well, you know, we could do this. Well, fluorescent given light bulbs is 0.52. We just found that. Fluorescent is 0.42, like what it said. They're not equal to, so no, they are not independent. All right. Let's go to the next page, page 22, and look at this one. Josie will soon be taking exams in math and Spanish. She estimates the probability she passes the math exam is 0.9. The probability, all right, I'm gonna write these down. She passes Spanish is 0.8. She is also willing to assume that the results of the two exams are independent. So if they're independent, then, well, here. Assuming Josie's assumption of independence, calculate the probability she passes both exams. So she has to pass the math and she has to pass the Spanish. Well, that's math times Spanish. There's no given here because they're independent. So 0.9 times 0.8, 0.72. All right, find the probability Josie passes at least one of the exams. So the probability of passing at least one is, well, the only way is 1 minus the probability of passing none. So 1 minus the probability that you don't pass any exam. Well, actually, that's going to be harder to do. Let's not do that. So let's actually do what the hint says. So she has to pass either math or she has to pass Spanish. So this formula is M plus S minus the probability of M and S. Okay, you need to know that. You need to know these formulas. You need to know A given B is probability of A and B over probability of B. Probability of A and B is the probability of A times the probability of B. The probability of A and B is the probability of A times the probability of B, but you have to account for A. So this is when A and B are independent. These two are dependent events. Those two are, dependent events. That's the only one that's independent. You need to know this one. A or B is A plus B minus where they intersect. All right, I think that's it for now. Put it right up here. All right. So probability of M is 0.9. Probability of S is 0.8. M and S we just found is 0.72. You can't just add these two because you're going to get something over 1. That's why you have to subtract where they intersect. 0.9 plus 0.8 minus 0.72, so we get 0.98. All right, skip that one. Let's skip this one. Okay. Day 6, center shape spread. Okay. Let's go here. So here's all my values. I have to find, they might ask you to put these values in the calculator and find the mean, median, mode, find out what the graph looks like. So to put the data in your calculator, you have to go to hit stat. And it's all right here, but, and then hit enter, and then just put the data in 34. Oh, if you have data in here, go up to the top and clear it out. What is going on upstairs? Sounds like a wrestling match. All right, 34, 38, 48, 41, 38, 61, 29, 46, 45, 40. Okay, then hit stat, go to calculate, hit first var stats. And then just hit L1. Leave that blank, and then hit calculate. Now, if you have the old operating system, you're gonna hit stat, calc, and it's gonna look like this. So hit second 1, and that'll put the L1 there. If your data is in L1, if it's in L2, then you hit second 2, then you hit enter, and I have no idea what data that is. All right, so 42, so this is the mean, that's the mean. Some of the x's means that if I added up all of these numbers, I would get 420. This is the 8.76, that's the sample standard deviation. 8.31, that's the population standard deviation. You can scroll down to, so the minimum is 29, the first quartile is 38, the median 40.5, third quartile 46, maximum is 61. If you wanted to graph this data, you hit second y equals. Hit enter, you want to turn that on, turn that plot on, and I would do a box and whisker chart. You could do any one of these. This one will show you the outliers, so well, let's do that one. And then hit zoom 9. It'll give you a nice statistics window. I don't know what the heck that is. Or that. Oh, here it is. Clear, clear. But you have to turn that off if you're not going to graph the statistics. So if you want to graph x squared, go up here and turn that off. If you want to graph that statistics stuff, turn it on by hitting enter. All right, zoom 9. So now this will tell you, oh, I have an outlier right here. And that kind of gives you the shape of the distribution. All right, so if they give you stuff in a chart like this, you're gonna go to stat, edit, and then put these values in. So 25,000. all this means is that these are employees' salaries. So 5 people are making 25 grand, 21 people are making 32 grand, one person's making 120 grand. So use your calculator to find the mean, standard deviation, and interquartile range. So then go to stat, calc, but the frequency, now you gotta do second to L2. And if you have this operating system, you're gonna hit stat, calc, second 1, comma, the comma's right above the 7, you have to hit comma, then second 2, if that's where your frequencies are. Then, well, I don't have the data in there, but then it'll give you the answer. Okay, so the mean is 42060. The standard deviation, in this course, always use the S. That's the sample. Well, wait a minute. It depends. Is it giving you the population? A small company has salaries for their 50 employees. Okay. All right. Since this is the entire population of 50 employees, then we will use the population standard deviation, 16567.93. All right, the interquartile range is quadrant 3 minus quadrant 1. Not quadrant, quartile. So scroll down. So we're gonna have 45,000 minus 32,000. 13,000. All right, what's the median of this set of data? Well, the median, right there, 32,000. Explain why the median is considerably lower than the mean. Well, because that person making 120K is inflating the mean. Because like to find the median, if you wanted to find the median, you would list all these, well, here. Like if I wanted to find the median of this data, that's a huge number. These are smaller numbers. So if I were to find the mean, like the average of this, maybe this is hourly wages. These are what your parents make per hour, and that's what Oprah makes per hour. Well, if I take the average of these, the average is gonna be like, I don't know, 80,000, not 80, I don't know, $7,000 an hour, which is not true. So the median just cancels out the highs and the lows, and it gets that. So, you know, outliers will inflate the mean. Does more or less than 50% of the data fall within one standard deviation? So within one standard deviation, we just take the mean, we add a standard deviation, and then we have to subtract a standard deviation to come up with a range. So 42,060 plus one standard deviation. And then do the mean, 42060 minus that one standard deviation. So this is within one standard deviation. If it wanted within two, just do this plus this plus this, this minus this, and then it'll give you within two. So do more or less than 50%. Well, the data that's falling in here, 32, is this. Yeah. So 21, 14, and 7. So that's 42 people. Sorry, 42 people are within 1 standard deviation. But there's 50 employees. So, yeah, more than 50% fall within 1 standard deviation. A lot more than 50%. There's only 6 people out of 50 that aren't within 1. Okay, here's some shape stuff. So when your data is symmetric, you want to use mean and then the standard deviation. When the data is skewed, you want to use median and then the interquartile range. So this is roughly, oh, this actually is symmetric. Okay, so it's like the same on both sides of it. And it is also bell-shaped. It is bell-shaped. I don't know if it's normal, but it's bell-shaped. This is symmetric, or roughly, it's roughly symmetric. And it's more uniform, uniformly distributed. Like each one of these has the same amount. Bell-shaped. This is right skew. This is left skew. So right tail, the tail is on the right, left tail. So there's, you know, a lot of my data is in this hump. A couple outliers here. A lot of my data is in this hump. And a lot of my data would be in that hump. Oh, okay. One thing to note, that my mean, my median, and my mode would all be in the same spot here. With skewed data here, so if my data is right skew, this is my mode, my median would be here, and my mean would be here, because outliers are inflating my mean. If my data is left skew, it's the opposite. Mode, my median would be here, my mean would be here. So a lot of questions they could ask would be like, oh, look at this data set. Is my mean greater than my median? And the answer would be yes. So know that setup. All right, so here's this graph. Would you just, on page 31, would you describe the distribution to be approximately symmetric or skewed? This is a little weird, but it's roughly symmetric, Maybe a little skew, but I don't know. I'd say roughly symmetric. Is the mean of the distribution closer to 15, 20, or 25? Well, 15, no. 20 or 25, it's going to kind of be around here. The standard deviation, is it close to 3, 6, or 9? Well, I would say, well, here, let's say the mean is 20. If my standard deviation is 9, that's over here, that's 29. All right, if my standard deviation is 9, that's 29. If my standard deviation, and then that would be 11. So it's definitely not 9. Is it 6? All right, here, so if it's 3, it's going to be between 17 and 23. That's going to be within 1 standard deviation. If the standard deviation is 6, it's going to be between 14 and 26 is within 1 standard deviation. If it's 9, that means it's going to be between 11 and 29. Well, it can't be that. Between 14 and 26, no, that's just too big. Because usually data is going to want to go out by 1, 2, or 3 standard deviations. It has to go out by 1, 2, or 3 standard deviations. So I would say choice 3. Because you're going to go 20, 23, 26, yeah, 17, 14, 11. So I went out 3 on each way. All right, we'll stop there.